Okay, hello everyone. So we are now at lesson 9.2. So in this lesson, we are going to learn how to solve systems of equations with three or more unknowns. Okay, so what does that look like? So we have here three equations with three unknowns. Okay, so the technique that we're going to learn first is called the Gaussian elimination. Now, it involves two steps. The first is to reduce this system of equation into a row echelon form, and then after that you can then back substitute and then you can get the values of x, y, and z. Now what is a row echelon form? Okay, that is the question right now, so that is the first question that we need to answer. Okay, so this is an example of a row echelon form. Okay, so as you can see here, the first row, right here has three uh, variables, right? X, Y, and Z. And the second one has two Y and Z only, and the third one only has Z. Okay. Now, as you can see here, there is a pattern there. It looks like a stair step pattern, right? Like an inverted staircase. Okay, so that is not the only thing that characterizes a row echelon form. Okay, the other thing is that x, if you notice here, the first terms, the coefficients are 1, right? So that is also a characteristic of the row echelon form. So we need to convert this. So this is not, by the way, this is not the row echelon form of this one. This is just an example row echelon form. Okay, we will get the row echelon form of our of this one later. Okay, so again, to recap, so we have here a stair step pattern, right? So three terms, two terms, and then one term on the left hand side. And then the coefficients of the first terms, so x, y, and z here, are all 1. Okay, so we need to do that. So how are we going to do that? How are we going to convert this this system into a row echelon form? So there are three different row operations. So number one, you can interchange any two equations of the system. So you can exchange their position. Okay. Well, let's just use the other one. Change their position, and then you can also multiply or divide each side of an equation by the same non-zero constant, or you can multiply both sides by any constant. Let's say 1/8 or whatever you choose, and then replace any equation in the system by the sum of that equation and a non-zero multiple of any other equation in the system. Okay, so we will see that later. Okay, so let's start. Okay, so before you start, it is good to examine first the equation. So let's take a look at our first equation here. As you can see, uh, the first term already has the coefficient 1, so that is very convenient for us. So how are we going to convert this into um, how are we going to delete or remove the x value here, right? So what are we going to do? So let's first label these rows. We label this as R1, this is R2, and this is R3. Okay, so this is just for you can make your own labels. Yeah, so I'm just going to use R1, R2, and R3. Okay, so what I'm going to do in order to remove x from R2 is that I'm going to multiply R1 by 2 by negative 2. So this whole equation by negative 2, and then I will add that to R2, and then the result of that I will replace to R2. Okay? So I'm going to do that. So 2 times R1 plus R2. So I'm going to replace it to R2. So this is just like some code that you can follow so that you won't lose track. So you can make your own actually. So I'm just going to follow what other sources are using. Okay, so negative 2R1. Okay, so let's multiply um, x minus y plus z is equal to 8 by negative 2. So what is the result of that? So negative 2x, and then positive 2y, right, minus 2z is equal to um, negative 16, right? Okay, so this is now our modified R1. We are going to add that to our R2. So let's put our R2 here. 2x plus 3y minus z is equal to negative 2. Okay, so let's try adding those. Adding these two. Okay, let's add them. So what are we going to get? So this will cancel out, right? So what do we get? 5y. 5y and then negative 2z minus z, that will be minus 3z, right? And then negative 18. Okay, so here, as you can see here, we now only have y and z. Okay, so if we move down here, so there we go. We have modified, this is now our modified system. Okay, so we will substitute this to R2, then we will get this one. Okay. Okay, so how are we going to proceed from here? Okay, so as you can see here, equation 3 also has three terms on the left-hand side. So if this is going to be a row echelon form, equation 3 only has to be, has only has to have one term on the left-hand side, and that should be z. Okay, so we're going to remove this 3x as well. Okay, so what are we going to do? Let's use our R1 again. So let's multiply R1 by negative 3. So let's write our code here. So negative 3 multiplied by R1, and then we will add that to R3. And then the result of that we will replace to R3. Okay, let's do that. So R1, so negative 3 times x, negative 3x plus 3y and then minus 3z is equal to, what's this, negative 24, right? Okay, so what is, let's just copy our R3, 3x minus 2y minus 9z is equal to 9. Okay, let's add them. Let's add these two. So this will cancel out, right? This will cancel out, then we will be left with y and then plus, so what's this, 9 plus 3, that will be 12. 12z is equal to 24, that would be negative 15. Okay, so we are going to substitute this to our R3. Okay, so this is now our result right here. So this is now our result, right? Okay, so the next step. Okay, so these are not necessarily the only steps that you can take. So there are many various ways that you can go about this. There are many combinations of row operations that you can do. So these are not, I'm just going to remind you that these are not the only options. There are many options, but the best thing that you can do is to select the most optimized way so that you won't be wasting time. Okay, so okay, now we our R2 and R3, R1, R2, and R3. Now R2 and R3 have two variables on the left hand side, right? And now we are going to manipulate these two in order to cancel out the y, right? So we need an equation with only z on the left hand side. So what are we going to do? Okay, let's multiply. Let's try this one. So let's use another color here. So let's multiply R3 by negative 5, and then we will add that to R2, because as you can see, I want to remove this 5y, right? It's equal to, we're going to replace this to R2. Okay, so let's do that. So negative 5 multiplied by y, negative 5y minus, so this will be 60, right? So plus 60z. Okay, and then this will be 75. Okay, and then let's write our R2. 5 minus 3z is equal to negative 18. Okay, so let's add them. If we add them, what do we get? So this will cancel out. So we will have 57, right? 57z is equal to 57. So that is very convenient because our z will be equal to 1. Okay, very cool indeed. So if we substitute that to our R2, what will we get? Okay, this is our R2. This is now our result, right? So let's use another row operation because if we remember correctly, um, it has to be a stair step pattern, right? And as you can see here, all of our coefficients are already 1. So this is really cool. So let's just interchange them. Remember, we also have a operation where you can interchange rows. So if we do that, so here is now our row echelon form. So very awesome indeed. So after that, how are we going to find x, y, and z? So we simply back substitute, okay? So we now have our value for z right here in the last equation, right here, z is equal to 1. So we're going to find y using equation 2. So using equation 2, so let's substitute z is equal to 1 to equation 2. So y minus 12 times z, which is equal to 1, this is equal to negative 15. So y is equal to minus 12 to 15. So y is equal to negative 15, adding 12 to both sides, and y is equal to negative 3. Okay, so we now have our values for um, z and y. So we're going to find x by substituting them to the first equation. Okay, so using equation 1, so let's substitute. So x minus y. What is our y? So negative 3, and then plus z, which is equal to 1, equal to 8. So what do we get? X plus 3 plus 1 is equal to 8. So x is equal to, so this is 4, and we're going to subtract 4 from both sides. So we will get 4. Okay, so we have here our solution. So the solution therefore is 4. That is our x, and then negative 3 for y, and then our z is 1. Okay, so this is our solution. So that is how Gaussian elimination works. So we need to convert it to row echelon form using the different row operations, and then after doing that, we can just back substitute and we will get our solution. Okay, so thank you for watching this video, and I hope you learned something, and we will proceed to other topics of 9.2 in the later videos. So thank you for watching. See you in the next video.